First, we're going to make sure we have enough knowledge with our normal functions. So to start with today, I want to play a game of spot the function in the wild. So first thing you have to tell me is what type of function is f and what type of function is g. So that is question number 1 for today. Tell me what each of these functions is. Because step 1 is you need to be able to identify. I agree with you, Asande. So f, I call it like the happy or the unhappy graph. In this case, because there's a 4, I call it a happy parabola, but it is indeed a parabola. What about g? So g, because it has this x in the fraction, this is going to be a hyperbola. I call, because there's a positive number, it's going to be looking a bit like that. Okay, now let's go to these questions. F of x, so it's the green one, is reflected about the x-axis. And we need to find the new equation, okay, the new equation, if we take f and reflect it over the x-axis. Okay, I want everyone to try and figure out how this equation changes when you reflect it over the x-axis. So I'll make it y equals, because this is a new equation, but this is going to have to change. What do you think is going to change when we reflect over the x-axis? Now, where is the x-axis? Well, the x-axis is here. Hey? Now, but I'm sure there's an algebraic way we can reflect over this. So, like visually, I suppose it would look something like that. But, we have to need a method. Can anybody remember a method from class? If you reflect over the x-axis, what I'm remembering is you change the sign in front of the y. In fact, let me just say it instead of, so you change the sign in front of the y. So this becomes minus y equals 4x squared plus 5x plus 1. So that's all you have to do. But when we write functions, we normally write it with the output variable by itself. So what am I going to do with this minus sign over here? And you can just put your hand up and answer me audibly. It's a tiny class today. So what do you think is going to happen for me to get that y by itself? Divide by -1 or multiply by -1 on both sides. Exactly. On this side, if I divide by -1, I get this. If I do, on this side, I'm going to get minus 4x squared minus 5x minus 1. Notice how the minus 1 changes all of these to negatives. But that makes sense because, like, if you reflect something over the x-axis, if you have something like here, all that happens is that the y value goes from whatever positive value it was there to a negative y value there. Okay, so that is A. Now for B, I want you to find me the equation of the g of x. So that's this one here, but it has to be reflected about the y-axis. Sorry, the x-axis, So tell me what the reflection of g over the x-axis is going to be. Where would you start? Thanks, Radiwe. I think you are on the right track there. And we have another student in the house. Welcome to Tandiwe. It is good to be with you. So if you reflect over the x-axis, you change the sign in front of the y. But remember that now we're dealing with this function. Okay. So now I need to get rid of this negative. I need to bring it across. And you know what I'm going to do? I'm just going to multiply both sides by -1. So what does that even look like? Well, it means that on this side, if I multiply by -1, I'm going to just get a y. But on this side, I'm going to get -2 over x plus 5. But watch out, this minus goes to this, and we get +6. Give me a thumbs up if you could follow the answer for B, how we reflected it about the x-axis. Okay. Awesome. Okay, so part 1 is done. We've done A and we've done B. Now you're going to have to modify your thinking a little bit for the next one. The next one is about reflecting about the y-axis. So I want you to go back to the function f, and now I want you to reflect it about the y-axis. Who can tell me how I reflect about the y-axis? What do I need to do? I'll give you a hint. If you look at it visually, let's say you have a point here. So let's say that was -3, 3. If you reflected it about the y-axis, it's going to end up over there. So which of the things? Is the y changing or is the x changing? Let me look at the chat and see what students are suggesting. So I want to reflect over the y-axis. What do I need to do with this function y? I don't change the sign in front of the y. I change the sign in front of the x. So wherever there was an x, I now put a -x. But when I square this, this becomes 4x squared, because -x times -x is positive x squared. This one becomes -5x, and this just stays +1. Okay, so that is C. Now you need to do D for me, and D is reflecting the function g over the y-axis. See if you can figure out what that one is going to be. The only thing that changes is if I'm reflecting over the y-axis, this is going to become -x plus 5. And I could leave it like that. Or if I wanted to, I could multiply the top and bottom by -1 in this fraction. And if I multiply, some people like doing this just to see kind of, to make it look a bit neater. So if I multiply by -1 on the top and bottom, I would get -2, and then this would become x minus 5, and that would be that. So that's just a trick for making it sort of get into a neater form in the denominator. Give me a thumbs up if you understand how I multiply the top and bottom by -1 here to make it look a bit neater, to get it into the standard form of a hyperbola. So Reniwe, if you think about why I did that, when I changed this to -x, we often like to have a positive x value on the bottom. So what do I need to do to multiply? Well, to change this, I need to multiply by -1. But I can't just multiply this. I also need to multiply at the same time that. And that's why it becomes positive x minus 5. And then on the top, -1 times 2 is -2. Fantastic. Okay, now we've done reflections. Let's look at translations. So translations are just where we move left or right or up or down or both. So I'm going to do the first one for you. So this is E. If f of x is shifted 1 right and 6 up. Okay, so I'm going to say, if I go here, there are a couple of different things in this question. There is the 4x squared plus 5 plus 1. If I want to shift it up, that's super easy. I just go plus 6 on the end. Give me a thumbs up if that makes sense to you. The fact that 6 units up is just a plus 6 on the end. Now, a slightly harder one is 1 unit to the right. And the reason it's 1 unit to the right is that with horizontal translations, it works the opposite way to our intuition. So because something is normally positive when it goes to the right, with the horizontal translation, this actually becomes x minus 1. And this is also going to become x minus 1. So that is how we deal with the 1 unit to the right. It's actually -1 there. Give me a thumbs up if that makes sense to you. No, okay. So the one way I can show you is imagine the graph of y equals x squared. It looks like this. Give me a happy face or a thumbs up if you are friends with y equals x squared. Okay, you're good friends. Now, imagine I take y equals x squared and I make this x minus 1. Okay, let's actually make it x minus 1. Now, if you think about this parabola, it has been shifted. The x-intercept for your original y equals x squared was x is 0. What is the x-intercept going to be for y equals x minus 1 squared? What is the x-intercept going to be for x minus 1 squared? How do you normally find the x-intercept? You make y 0. So what x value is going to make that 0? What does x need to be to make this equation kind of work? Can anybody see that the x-intercept must be at x is 1? I see Tandiwe has seen that. Give me a thumbs up if you're okay with x being 1. Okay, but now what does that mean? That means my new graph friend is over here, x minus 1 squared. It doesn't go through 0 there. It looks like this. But ladies and gentlemen, look at what's happened. When we went from y equals x squared to y equals x minus 1 squared, the whole thing just moved 1 unit to the right. Even though the equation said x minus 1, it moved 1 unit to the right. So does that help you understand why, if we move to the right, we need to actually use minus in the variable there? Give me a thumbs up if that helps you understand why I was using x minus 1 here. Give me a thumbs down if it wasn't helpful. Okay. Okay. So we are really getting used to this idea of changing or transforming a function. So the next one you guys are going to do for me, I want you to do f, and I want you to try and do it by yourself and just put the answer in the chat. See if you can do it by yourself. And let's have a look. Some other people may have joined us. Oratile, welcome, Oratile. It's good to have you with us. I like to write them like that before I actually start. So 4 units to the left, 2 units up. Well, the 2 units up is quite simple. Now, what about 4 units to the left? That's going to be x plus 4. So what is this going to be? It's going to be 2 over x plus 9 minus 4. Give me a thumbs up if you're okay there. Okay, I think things are getting much easier now. Let's just do one more of these, and then we can move on. So I want you to do I for me. Just do I, and then we're going to move on. Actually, I think we should draw a graph. That would be a good practice. Okay, so 2 over x plus 5 minus 6. If I want to go 4 units down, I go minus 4. If I want to go 1 unit to the right, that should be x minus 1. So now the question is, what's this going to be? It should be that. Reniwe says 2 over x plus 5. All right. So the plus 5 is there, but remember, you go 1 unit to the right. So Reniwe, do you agree with me on I? Are we happy, or are we? So what we do is to go 4 units down, we have the minus 4 over here. So those two together give us minus 10. And then for 1 unit right, we have the x minus 1. But x minus 1 plus 5 gives me the x plus 4. Just give me a thumbs up anyway, if that makes sense. Fantastic. Okay, do you know what? I feel like we haven't had enough practice drawing graphs. So for our next little bit of top-up understanding, we are going to draw the graph of G. So I'm going to give you 3 minutes or 2 to 3 minutes to draw the graph of G. And all I'm going to say is there's a couple of important steps you need to think about. Where are the asymptotes? Where are the intercepts? So I want you to do that working out, and then I want you to draw me a hyperbola. And then we'll talk about that hyperbola in a moment. But first, you do some working out for me around drawing a hyperbola, because I feel like the hyperbola doesn't get the attention it deserves. So we're going to give it some quality time. So ask yourself, what are the asymptotes for this function, this hyperbola? Maybe even write them in the chat if you're feeling generous. Okay, so I think that the asymptotes are at -5 and y is -6. So visually, let's just make sure we know where they are. So let's say that this is x is -5 and this is going to be y is -6. Now, the other thing we need to know, okay, so this point over here is actually quite important where the two asymptotes meet. But now, because there is a positive value there, when we finally draw this hyperbola, we're actually going to be playing in those two quadrants, although visually it will be here and here. But the next step we need to do is we need to find the y-intercept if there is one and the x-intercept if there is one. So find me those. I might need my calculator for that. Okay. So, what do we have? 2 divided by 5 minus 6. We get -28/5, or as a mixed -5.6. And then what do we get for the x-intercept? X-intercept. We have to make y 0. So now we need to solve this equation. And just to give you a little bit of help, I'm going to show you how you can move things around. What do you get for the solution at the end here? What do we have here? 6x plus 30 equals 2. Is anybody else getting quite a big negative x value? Oh, wait, hold on. 6x is -28. So then x is -28/6. Divided by 6. -14/3, or as a decimal, -4 2/3. Give me a thumbs up if you followed that bit. Okay, so now when I draw my graph, I'm going to get minus 5.6 on the y-intercept. So it's going to be about there, because that's where that is. And then here, it's going to be about there. So the graph is going to look like that, and then like that. But then on this side, it's also going to have another part like this. And then this function is called the function g. And I should label this minus 4. Oh, try that again. Minus 4 and 2/3. And here it would be minus 5.6. And that would get you full marks for that one. Okay. Thumbs up, thumbs down. Do you understand how to draw a hyperbola? Fantastic. If you had to generate another point on this hyperbola, can anybody tell me how I could get another point on this side? Because I've labeled 2 points, and sometimes you need to have a point to anchor this part. Can anybody make a suggestion how I could get a point on this side? All right, I'll give you a hint. If you go to the left of minus 5, let's say I get the number minus 6. If I want to know what y value is on the red graph when x is minus 6, all I need to do is take the function g and put a minus 6 in. So we go 2 over minus 6 plus 5 minus 6, which is the same as 2 over minus 1, because minus 6 plus 5 is minus 1, is that. So that's minus 2, minus 6, that's minus 8. So do you know what this point over here is? I can even extend this line here. This is going to be in line with minus 6, and then this over here is going to be in line with minus 8. Or I could label the point here minus 6, minus 8. Give me a thumbs up if you followed that expedition to find another point on this side, because you can do that. Hey, that's what this rule does. It says, give me an x value, I'll give you a y value. Okay, I think that's been a great first half of the lesson. We've done some great consolidation on functions, but you know what time it is now? It is break time, and I want you to step away from your table or your desk or your chair or whatever it is that you are currently sitting on. And I want you to join me in standing up. And the lights are on, so that's good. It's a bit dark because we're going to have thunderstorms in Cape Town today. And we don't often have thunderstorms, but apparently that's what's coming our way. Okay, let's start with some deep breaths. Breathe in. Breathe in. Breathe in. Breathe in. One last breath. Okay, so some nice oxygen in my body. That's great. My body appreciates that. Let's loosen up, get all that stress and anxiety out of our bodies. Let's shake our arms around like we're like a rubbery doll or one of those things that blows in the wind. You know, have you seen those guys when they're advertising and their arms just go whoop, whoop. Shake out the legs. It feels so good. Oh my goodness. I can feel the stress of the day melting away. And then arms to the side, just a little bit, not too much. You don't want to hurt anything in your back or your hips. But as you relax, you'll notice that you are going further because you're relaxing. You might even hear some clicks. Okay, and then let's roll the shoulders back. Roll the shoulders back, roll the shoulders forward, and then give it one more shake in the arms, one more shake in the legs. And I feel so much more relaxed. Oh my goodness. Okay, last thing, blood flow to get us awake, ready for part 2. And you know what's coming. It's a jumping jack. This is what a jumping jack looks like. And we are doing 15 in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whew. And that still gets me, those 15 jumping jacks. Give me an emoji if your heart rate still gets whacked by the jumping jacks. Like, I've been doing this all year, and those 15 jumping jacks still get my heart rate. Okay, I see the emojis. Fantastic. All right. So, part 2 of today, we worked on, in part 1, transformations. We worked on some skills. What I want to do here is I want to check some other parts of your skills. So what I want you to do for me is I don't know if intersection points exist, but I know this is a parabola. This is G is an unhappy parabola. So I don't know where it is, but it probably looks like this. This is a negative straight line going through -4. So it probably looks like that. My guess is that there are 2 intersection points here and here. I want you to try and find them for me. What should I do first to find the intersection of F and G? Who can give us a tip? Sunday, you are on the money. Equate the 2 equations. So you've got y equals -3x minus 4, and you've got y equals -x squared plus 2x minus 3. If you equate these 2, what you do is you eliminate one variable, and now you can solve for x. So I want all of you to find me my 2 x intersection points. Visually, there would be one here, and there would be one here. So off you go. And there may be something called the quadratic formula involved, which would be here. If you need it. Okay, what are we getting? So if I bring this across, I get x squared minus 2x plus 3 minus 3x minus 4 minus 5x minus 1 equals 0. Just to check, give me a thumbs up if you got x squared minus 5x minus 1 as your equation. Okay. Now, you can't factorize that easily. So it may be that I don't know if there's an answer yet. We're going to have to use the formula. So, because I can't factorize that easily. So A is 1, B is minus 5, C is minus 1. So if I go to my formula, I go minus minus 5 plus minus, and then I go B squared. So what's B squared? It's minus 5 squared minus 4 times 1 times minus 1 over 2 times 1. And now I've got 5 plus minus. Now, this thing inside here is called delta. What have I got? 25 plus 4, I get delta of 29. And on the bottom, I've got 2. Okay, so we do get x-intercepts, but I think they're going to be decimals. So see what you get. 5 plus square root 29, and then divided by 2, I get 5.19 for the one, and the other one, 5 minus square root 29 divided by 2, I get minus 0.19. Give me a thumbs up if you're there with me. Fantastic. And now, because this is a coordinate, I actually need the y coordinate that goes with these. But the good news is that's super easy, because all you do is take either of these. I would choose the simple one, and you just take the x value 5.19. So you go minus 3 times, times, minus 3 times 5.19 minus 4, and that will give you the one value. And the other one would be minus 3 times minus 0.19 minus 4. So minus 3 times 5.19 minus 4, I get minus 19.57. And then here I get minus 3 times minus 0.19 minus 4, and I get minus 3.43. So this would be that, and this would be that. And so the 2 points are going to be, they're going to be, if I called this one A and this one B, it looks to me like this one would be over here. That would be A, and that one over there would be B. Give me a thumbs up if you understand why I chose to put A over here and B over here when looking at the points. Awesome. Okay. I want you to do another one like this, but you are going to do for me this one. So find me the intersection points of these two functions. And I'll give you some time to work on that. Actually, So it feels like we have to solve this equation now. Who can solve that? I feel a bit stuck. How do I deal with this thing? Any ideas, everyone? Do we transpose the 3 first? That's a good idea. I think so, anyway, because it makes life less complicated if I do that. So for me, anyway, I think you're on it. And then if I want to get rid of this, actually, if it's divide on this side, I can now, but I need to remember this whole thing would then get multiplied by that whole thing, and then I'm left with -1. Give me a thumbs up if you follow me and Renee's steps, where the first step was to bring this across to get the +3. But now I need to make sure, remember this whole thing, when it comes across over here, another way of thinking about it is I'm just multiplying both sides by x plus 2. And then this cancels out, which leaves the -1. And then on this side, I have to multiply. So you've still got some more cleaning to do now. So I'll give you some more time to solve that. Okay, so what do? We go. Oh, you know what? I'm going to move things to the other side. It makes so much easier here. 0 equals 4x squared plus 5x minus 7. Give me a thumbs up if you got that. Okay, but now you still need to find me your x values. So what are the solutions to this equation? Go and find them for me. And then we still have to find y values after that. So we haven't actually got the coordinates or the intersection points yet. Now, I wonder what delta is going to be. Ooh, okay. 4 times 4 times 7 plus 25. So what I get for I get minus 5 plus square root of 27 divided by 8. 3, or x is give me a thumbs up if you get those x values as your solutions. Okay. And then to find the y values, all you need to do is take those x values and put them back into the easiest of the two equations. So let's have a look. What's the easiest? I think the easiest one would just be the minus 4x. So basically, I'm just going to go minus 4 times 0.83. So minus 4, which is minus 3.32, or y is minus 4 times minus 2.09. And then I get 8.36. And that would be that. But 8.3. Okay. If you carried, okay, there might be a slight rounding difference. If you carried all the decimals from here and you didn't cut them off, you'll have a slight difference here and here. So Reniwe, that's why, because you carried those through. So that's fine. That's not a problem. All right, everyone, you know what? I think this is a good point to stop at for today. I think we've done enough for today and consolidate. But what we're going to do next week then is I will talk a little bit about inverses. Is there anything in particular that you would like to know about still today to do with functions? So we've been kind of just exploring. Is there something that, like, when you think of functions, you'd really just like a little top up? Does anything come to mind? Otherwise, give me a party emoji if you're like, okay, that's enough for today. Let's wrap this party up. All right. It has been good being with you. Thank you so much for coming. I know it takes extra effort, but if you build good routines, results will come. So to you, Asande, Reniwe, Tandiwe, I wish you a good evening. Oh, can we do more practice on finding coordinates? So can you explain what calculus is? Okay. Well, before I head off, let me just have a, let's have a look here. So in the next lesson, we will practice, we will also practice more intersection points. And then the other question was, what is calculus about? So what calculus is about gradient. So if you think of a straight line graph, a straight line graph will have one consistent gradient. So in this case here, the gradient of the straight line is 2. But if you deal with a graph that has curvature, so let's say you have a parabola, the gradient of this graph over here on this side, you can visualize it by a little tangent line, is negative. The gradient at the bottom is 0, and the gradient is positive and getting steeper as you go up this curved graph. Calculus is the study of how do we find the gradient at different points on the graph, because the gradient is changing with a curved graph. So if you have a graph like this, how do you find the gradient of this graph at different places on the graph? Does that help with the calculus question?